table too. So everything we're doing is already chapter 1, and it's already for this first unit, okay? And if you look over here, let's go ahead and put together our periodic table. Okay, so we're going to draw the organic chemist periodic table. I think that might be the better way to start. I don't like that page yet. So my periodic table for organic chemistry start like so. We started to say in class that we have fluorine, we have chlorine, we have bromine, and we have iodine. We started there. We moved one over and we had oxygen and we had sulfur. We moved one over, we have nitrogen and we have phosphorus. We move one more, we have carbon, and some way far away, we have hydrogen over there. Okay? And this is our periodic table. Pretty much all of it. All right? And there's my little hydrogen over there. This one is group 7. And these are the halogens. We started to say that. This is group 6. We call this the oxygen family. This is group 5. They call that the nitrogen family. And this is carbon. And carbon, it is all about carbon. This is our big, important element over here. When I go back to the periodic table and I see hydrogen 1, would you be able to draw the electronic configuration for hydrogen? Would you be able to do it? Yeah? The electronic configuration for hydrogen would be what? 1s1, right? 1s1. When we look at hydrogen, hydrogen is way up there in group number 1 on the first energy level, right? On the first energy level. The first energy level, what sublevels do you have? On that first energy level, what sublevels do you have? Only one, right? Sublevel S. And that's all you have. What happens when you get to the second energy level? How many sublevels do you have? You have 2. You have the 2s and the 2p, right? And you can put a maximum of how many electrons on that second energy level? Maximum. 8. All right. Let's create an Aufbau diagram, all right? So let's go ahead and we're going to call this Aufbau diagram. Have you heard of this? So we're going to call it Aufbau diagram. And we're going to call it Santiago style. And I'll tell you why it's going to be called Santiago style momentarily. All right. So on the first one, we have the 1s. And I go 1s, 2s, 3s, 4s, 5s, 6s, 7s, 8s. Take a look at your periodic table. If you look at your periodic table, right, when we come over here and we look at the periodic table, oh wait, you're not seeing my 8s. Ooh, what's going on? There's the 8s. And I think some of you are going like, what? If you look over here in the periodic table, all you have is 1, 2, 3, 4, 5, 6, 7. There's no 8. You see that? That's Santiago style. There's no 8 yet. We don't have any elements there. I'm doing it for a purpose so that I can figure out all the many sublevels there are. So when I get to the second, and I go to 2, in level 2 you have P, and I went 1, 2 down, I'm going to come 1, 2 up. The P's are only from the second energy level to the 7th. Okay? And then I fill them all in. So there are P's in the 3rd, in the 4th, in the 5th, in the 6th, and in the 7th. I'm going to go 1 in, I'm going to go 1 over. When I go 1 over again, I'm going to go 1, 2, 3, and the D's begin there. In 1, 2, 3, the D's begin there. In 1, 2, 3 up, the D's end there. Is everybody seeing? I came 1, 2, 3 down, and I went 1, 2, 3 up. These are the only energy levels that have the D sublevels. And so there is 3 Ds, there are 4 Ds, 5 Ds, and 6 Ds. And we're done with that. And then we'll do the same thing with the Fs. There's only Fs in the 1, 2, 3, 4, come 4 down. And you go 1, 2, 3, 4 up. So these are the only energy levels that have those sublevels. This makes it really easy to memorize. Okay, it makes it very easy to memorize how you would do the electronic configurations. Take a look at this. Again, remember how I said that I failed art? Well, for me, this has some form of symmetry that I'll be able to remember. And there will be an ordering where you will always be correct in how you fill them up. I know, again, depends on who you're coming from. I know that Dr. Higashi wrote the 1S at the bottom, 2S, and we go 2 P, 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 3S, 3 P, 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 4S, 4 P, P, P. Remember that? If you came from Dr. Higashi, that's how you will do it. I don't know how the other professors do it, but this is a really easy way to remember. We're going to use it momentarily. Okay, the order in how you fill them is always in a diagonal line. So we will always start at the beginning with 1S, and we come down this way. And then you go back up, and then after you fill the 1S, then you will do the 2S. And again, you fill that, and you go back up, and you will do the 2P and the 3S, right? So always your line begins at the top of your little inverted, missing a part volcano, and you always go back to that very top. Okay, what else are we missing? What else are we missing in order to put this all together? You're missing the maximum number of electrons, right? That's the other thing that you're missing. Maximum number of electrons. In the S, you can put a maximum of what? What is the maximum number of electrons that you can put in the S sublevel? S, 2. And in the P, how many maximum in the P sublevel?
6.
How many? I hear 6 or 8. How many people say 6? Raise your hand. Okay, 6 is good. There are 6 maximum in the P. How many on the D sublevel? 10 in the D, and in the F?
14.
14 on the F. Okay, so that's what we're having for those. All right, are we ready? So when I say write the electronic configuration, let's say for oxygen, right? So if we ask you to write the complete electronic configuration of oxygen, what do you do? What are you going to do when somebody says that? Write the complete electronic configuration for oxygen. What are you going to do? First of all, well, you hope that she has given you a periodic table, right? So you're hoping for that. You come to the periodic table, there is oxygen, and you look at the atomic number. Remember that in class even today we said the atomic number represents the number of electrons and the number of protons. For the electronic configuration, electronic, we're looking at really the electrons, right? So you're looking at the electrons, so you're looking at that number. So every time you're starting at the very top, so you start with the 1s, you put 2 in the 1s, you are done. Then after that, you go back up, and you're doing the 2s, and you put 2 there, and you're done. After you do the 2s, you go back up, and now you're at the 2p, and at the 2p, I count. I have 2, 4, I need 4 more to get to 8, and I double check. So I have 2, 4, and 4 is 8. That should be your complete electronic configuration for oxygen. Okay? So now, when I say to you, oh, go ahead and name the element that this correspond. Now we're going like backwards, and now all we're gonna do is we're gonna go ahead and look at the complete electronic configuration. And this time all you need to do is look at the superscript. I have 2, 4, 6. That's a total of 6 electrons. I go back to the periodic table, and number 6 is carbon. So that we will be referring here to the atom of carbon, right? Carbon is this, the symbol is C, the name of course is carbon. I'm sure some of you are extremely bored already because this seems to be so the same, right? All right, let's do the other one. So what happens with the other one? What are we talking about? We're talking about phosphorus, 2, 4, and 6 is 10, 12, 15, so there's 15 here. We're looking at the atom P, which is phosphorus. Call it a day. All right, you're working. So you're going to be using your AFPAL Santiago style. Did you see why I call it Santiago style? Why did I call it Santiago style?
Because of the 8?
Because the 8S does not exist. But the story doesn't work without it. Is everybody? So if I don't write the 8S, the 1, 2 down, the 2 up doesn't work. That's why I said it doesn't exist. We don't have elements in there yet. But who knows? Maybe you'll discover some and they'll fit that. So don't tell Higashi, she says that there's an 8S. It doesn't exist. It just fits the whole thing. Well, using this, go ahead and write the complete electronic configuration for element 4 BR35. No Google, just go ahead and use this whole thing. So bromine, which is 35, see if you can get it all done. Again, this should be total review. So you're doing bromine 35. The only reason why you don't see it is because I'm letting you see the alpha. Bromine 35.
S2.
3S2, 3B6, 4S2, 3 what? 3D, 10, they're telling me 3D, that D went definitely bad. And then 4P5, is everybody agreeing on that? Yeah? 2, 4, 10, 12, 18, 20, 30, 35. Okay, so that's correct. Can you imagine we have to do this every time? Like, hello, no. Right? We're not going to do this every time. This is just not going to work. But could that be part of test 1? Well, yes. This is all stuff. Can you write the electronic configuration of the valence electrons of bromine? What are valence electrons of bromine? And somebody tell me what are the valence electrons of bromine from this complete electronic configuration? What are they? 5? How do I know? What is the definition of valence electron? What is valence? What do they mean by valence electron? The outermost, the furthest away from the nucleus. Okay, well, 1 isn't it, 2 isn't it, 3 isn't it? So 4 are the outermost. 4 are the outermost. Okay? So the valence electron of bromine, the electronic configuration is 4s2, 4p5. Where would you find bromine again? You will find bromine where? 2 and 5. You will find bromine in group 7. You see where bromine is in group 7. The 7 came from the valence electron. I'm in group 7 because I have 2 and I have 5. That's a total of 7. So all of these, all of the halogens, every single one of the halogens is going to have the same valence electron. What's going to be different? They're all going to be S2p5. All of them are going to be S2p5. But I'm going to be 2s2p5. I'm going to be, I'm going to be 3s2p5. Everybody? Oh wait, I'm going to be 4s2, 4p1, 2, 3, 4, 5. So what happens with iodine? What's going to be the valence electrons for iodine? Where are they? Right it. What would they be? 5s2, 5p5, right? So they should be here. If you're iodine and I want to know what are your valence electrons, the valence electrons for iodine, put your finger on iodine, you were in group 7, and then you go all the way, you're on the 5th energy level, so you'll be 5s1, s2, these guys don't count, those guys don't count, and then you're 5p1, p2, p3, p4, p5, right, so that's the 5s2, 5p5. Somebody, is everybody okay? Everybody okay? All right, let's do one more. Let's take a look at selenium. Would you be able to do selenium? So here is some of the things that we can ask. Write the complete electronic configuration for selenium. That's number 1, right? The valence electrons So what we can do, I will go ahead and give you the number, the atomic number for selenium. So selenium is 34. Oh my God, this is so dumb. Okay, sorry. I just saw. Forgive me, I've been rusty. The last day I was at Solano was May 18th. All right, this is so dumb. Sorry, don't mean to insult you. What are we going to do with selenium? Take one away from bromine, right? Oh, but don't expect this on a test. I mean, this is like, what were you thinking? Right? So we did bromine with 35, selenium with 34. Okay, now, this is an insult to all of us. So we'll take one off. No. Let's change it to sulfur. That's too silly. Let's change this to sulfur. Sorry. Let's change it to sulfur. That's too silly. And sulfur. How many does it have? 16. Let's do sulfur. It should be much easier. And then we move out of this. How many of you remember all of this? Raise your hand. Well, those hands are like weekly up. They're like, I remember all of this. They're like, not, I own this. All right, so let's do sulfur fast, help me out. So 1s2, 2s2,
2p6, 3p6, 3p4.
I don't know, 2, 4, 10, 12, 16. So 3s2, 3p4. All right, if they ask you to go ahead and draw the valence electrons for sulfur, this one should be too easy, right? Should be too easy is those last one, right?
Yeah.
So it's 3s2, 3p4. Which group would you find sulfur? You would find sulfur in group 6, right?
Mm-hmm.
Everybody okay with all of this? This is old stuff, old stuff. How did Lewis draw this? How would you represent Lewis' structure for sulfur? How do we do the Lewis structure for sulfur?
2 lone pairs.
We put sulfur there, right, sulfur there, and then supposedly the way that Lewis dots say to go around this, you start with your 1 and 2 and 3 and 4 and 5 and 6, right? Is everybody there? That's how Lewis said to do it. There were 2 kinds of electrons in here. These guys that are paired are called what?
Lone pair.
These guys that are paired are called lone pairs, right? So these guys are lone pairs. They're also called, what else are they called? Anybody else knows any other name? Can you bond with these guys? Not normally. I mean, you know, we destroy everything that's normal in this class, you'll find out. But normally, these guys are called your non-bonding, right? So they're called your non-bonding electrons, right? This guy that is all alone is going to be your unpaired electron, right? So this is your unpaired electron. This is the electron that is also used for bonding, right? So this will be your bonding electron. So we call this guy the bonding electron. In your other class, we did a lot of ionic bonding. Does anybody remember what ionic bonding is?
Metal
How
and
do you
non-metal.
describe an ionic bond? You're talking to somebody, you're trying to, you want to be a tutor, and you want to tutor M10. So an ionic bond, what are you going to say about an ionic bond?
Transfer of electrons.
Transfer of electrons, he said.
Metal, non-metal.
So an ionic bond is going to be a metal with non-metal. What is a metal? What is a metal? Yeah, anything you want. Shiny, malleable, ductile, conducts electricity. Where are they located in your periodic table? There's that great step ladder. Has everybody seen the great step ladder? And to the left of the step ladder are your metals. So in order to have an ionic bond, you're going to have any one of these guys with any one of these guys. That's what they mean by metal and non-metal. Your metals do what? They conduct electricity. Your metals do what? Metals give away electrons. And the non-metals do what? Accept electrons. We're not doing ionic bonding in this class. We're only doing covalent bonding in this class. So we're all about covalent bonding. So what was covalent? So this is gone. Everybody, goodbye. We're done. That was a whole year of that. We're done with that. This year we're just looking at covalent bonding. Covalent bonding, what are you doing? You're sharing electrons. He's sharing electrons. Again, I know that you all have probably done this before. So, when in Rome, you're kind of going to do like the Romans do, that story. I think it was there for a purpose. So the one thing that I want to do in order to draw Lewis structure of this molecular formula, right, we're asking you to draw Lewis structure. We're going to kind of follow the same thing that we do in order to calculate molar mass. Remember, this is how you do to calculate molar mass, that you have 1 atom of carbon and 4 atoms of hydrogen, right? That's how you do molar mass. But this time, in order to draw Lewis structure, we're going to go and find it on the group number, okay? So I am carbon and I'm in group 4. That means that carbon has 4 valence electrons. You need to calculate, you're calculating the total number of electrons. Okay, I'm in group 4. I have 4 hydrogens and hydrogen is in group 1. So that takes care of 4. So there are 4 and 4. There's a total of 8 electrons. Oh madre de Dios, I cannot even write. So there's a total of 8 electrons, and then what else do you have to do in order to do this? What else are you doing? When you do Lewis structure, what else do you need to figure out? Who's the central atom? Right, you're figuring out who's the central atom. Obviously, the one that you have 1 of, so I only have 1 carbon, it should be the central atom, and then you would go around and put the hydrogens all around. Right? Can you do it like that? Is everybody agreeing with that? The carbon atom in the center has a total of 2, 4, 6, 8. So it has a full octet. Carbon has 1, 2, 3, 4 around it. Right, so there's 4 around it. And the hydrogens all have their electrons, so everything seems to be okay. This is a normal molecule. This is the simplest of the hydrocarbons. Its name is methane. Life doesn't quite work like this in this class. And so when we come over here and we do this, and say we have CH3 minus, then how do we calculate that? Let's go ahead and calculate that also, CH3 minus. And we're following the same way that we just did, right? We have 1 carbon, we have 3 hydrogens. Again, we go to the periodic table. Carbon is in group 4, so that takes care of 4 electrons. Your hydrogens are in group 1. That's a total of 3. So this is 7. What happens when you have a minus? You add 1, right? This is the only class that a minus is a plus, right? So a minus means you have 1 more electron, and then you go ahead and you add them in. Yes? So you add 1 more. There's a total of 8. Total of 8? Yeah? So I do the same thing. I have carbon, and I have 1, 2, 3 hydrogens. 3 hydrogens. That takes care of 2, 4, 6. Right? That takes care of 2, 4, 6. But I have a total of 8. So that will represent a lone pair. I'll go ahead and I'll give them to carbon like so. Yes? And in your other class you did this. calculate the formal charge. I'll call it formal charges. I need to know who's got the extra electron. I mean, I know you put it on the outside, right? And maybe for this example, it's quite obvious, right? For this example, it might be quite obvious. But I do know that carbon has 4 valence electrons, and then I'm going to subtract the number of electrons that belong to carbon in the structure, okay? The lone pairs are mine, so I have 1, 2. The bonding pair are half for you, half for me. The book has a very complicated algebraic equation to say the lones are mine, the bonding are half. Everybody? So that means that I have 1, 2, 3, 4, 5 that are now mine. The 4 minus 5, that's how you came up with the -1. So that negative charge is the carbon. The carbon carries a -1 charge. A carbon with a -1 charge is called a carbanion. I see your hand up. Yes. The 4 is the valence electrons of carbon. So any atom that is, any element that is in group 4 will have 4 to begin with. 4 valence electrons. Let's do one more and then I'm going to let you go. I promise. Oh, well, it's almost done. Let's do one more and see if we understand what we're doing here, okay? So let's try this one and I promise I'll let you go after this. You didn't think we were going to start? You know we were going to start right away, no? Okay, calculate the total number of electrons. Let's start there. So we want to calculate the total number of electrons. You know what I mean by this, right? You're doing this. That's what we mean by calculate the total number of electrons. So we're doing exactly this. Everybody coming up with 14? 14 is the magic number? 14. Okay, so people are coming up with 14, right? 14? Yes? I have 1 carbon. Carbon is in group 4. You're looking for the group number that they're in. Group number. That's group number tells you the number of valence electrons. So hydrogen is in group 1. Oxygen is in group 6. So that's a 6. Altogether this is 13. And a minus is a plus. Right? And a minus is a plus. So when I go ahead and I add that one, there's a total of 14 electrons around the ion. This is an ion. Okay, if we follow the same thing we have been doing all along, the carbon had 1, 2, 3 hydrogens, and now you're bonded to the oxygen, right? And we've been following that same trend. The carbon with the 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. Now we have 1, 2, 3, and we've added oxygen to it, right? So when I count, I have 2, 4, 6, 8. So there are 10, 12, and 14. We put the brackets and the minus. Who carries the extra electron, right? Who's got the extra electron? Again, it seems clear that that carbon has 1, 2, 3, 4, right? But when I look at the oxygen that is supposed to have 6, the oxygen is supposed to have 6, and now the oxygen has 2, 4, 6, and I share that one. 6 minus 7 is a negative 1. So we'll do a lot more of these. If you need more practice, and we're going too far ahead, it's all here in number 4, but we'll do more of that. I mean, I just wanted to start. All right, before everybody leaves, the students that are